Hi everyone, in today's lesson we're going to talk about how to apply exponentials to word problems. So this first formula that you see here is what we call an annual compounding formula, or in other words, this is for exponential growth and decay. Okay, so this formula is used when I'm exponentially growing something or exponentially decreasing something. So the best way that I can explain this is through an example. Okay, let's read example number 1. So it says that David bought a new car at a cost of $25,000. The car depreciates at approximately 7% of its value each year. What will the car be worth at the end of 10 years? So if we look here at the formula, A equals P, 1 plus or minus R to the T. We choose plus or minus depending on whether we are increasing or decreasing. Now the word depreciate means to lose value. So depreciate means to go down. Okay, so we're going to choose the minus sign. So let's write down the formula first. So we have A equals P, 1 minus R to the T power. Now A stands for the ending amount, how much the car will be worth at the end. So that's the variable we want to solve for. P is the initial amount. Initial is another word for starting, so beginning amount. So we see here that David bought the car for $25,000. So that goes in for P because that's how much he paid for the car initially. 1 minus, now my rate. R is the rate inserted as a decimal though. So if I have a depreciation rate of 7%, remember the number 7 looks like this. We move the decimal place 2 places to the left. So we put this in as 0.07 to the however many years, where T is the time. So we have 10 years. Now honestly, all you're going to do is type this into the calculator just the way you see it and get an answer. So take a minute, pause the video, and put this into the calculator and hit resume to see your answer. Okay, you should have gotten approximately $12,099.56 if we round to the nearest cent. I know it didn't specify. Okay, so that's how much the car would be worth after 10 years. Okay, let's do an example where I would be increasing or exponentially growing something. So let's read this example. It says Nick invests $500 at a bank offering 7.5 interest rate. Find the amount of money to the nearest cent of the investment at the end of 5 years if the interest is compounded annually and there are no additional withdrawals or deposits. Now this, if the interest is compounded annually, that just means one time per year. So one time per year you are getting interest. Okay? So let's write down the formula. A equals P. Now this time we're going to use the plus sign. 1 plus R to the T. Interest in a bank account is a good thing. You're gaining money. That's why we're going to choose the plus sign. So if A is the ending amount, that's what we want to find out. P is the initial amount, or how much we start with. We're starting with $500. And we have an interest rate of 7.5%. So 7.5, we take the decimal, move it 2 places to the left. So it's 0.075. And we're going to do 1 plus that. And we want to know at the end of 5 years, so the time is 5. And if we type this into the calculator, just the way you see it, we will figure out how much money Nick will have in his account after 5 years. So type it into the calculator and then hit resume when you're ready. Okay, you should have gotten approximately $717.81. So at the end of 5 years, Nick would have grown his $500 to $717.81. Okay, we're going to skip 3 and 4, and we're going to go on to the next page. Okay, now this is a formula that you see here that we are going to use when I'm compounding your interest other than annually. Okay, so we're going to talk about an example here, and we're going to go through all the different types of compounds and what will happen to your money after it's been compounded that amount of times. So we're talking about Nick investing $1,000 at a bank offering 7.5% interest rate. Find the amount of money to the nearest cent of the investment at the end of 5 years, if compounded which way. So let's talk about an annual compound. What that means is that annually means once a year. So that is what the N will be. Okay, N is the number of compounds per year. That just means how many times am I calculating interest. So number of times we calculate interest. Okay, so annual we know is once a year. Semiannual is twice a year. Quarterly is 4 times a year. Think how many times you get a report card every quarter. Monthly is 12. There are 12 months in a year. And daily is 365. So there's a different formula when we are not using annual. So N is 2 and 4 and 12 and so on and so on. We have to use this formula. Now I'm going to show you that this annual formula that we learned on the other page is the exact same thing as this. So let's plug into this formula, N being 1. So A is equal to P 1 plus R over 1 to the 1 times T. All I did was plug in 1 to this formula here and here. So what happens here when I do R divided by 1? That's nothing but R. So 1 plus R. And then 1 times T is T. So this formula here you can use all the time, but this is how we derive that annual formula that we just did before. So let's find out how much Nick made. A equals P, 1 plus R to the T. So if he invests $1,000, that's my principal, with an interest rate of 0.075 to the 5 power, let's see how much money he'll make. So take a minute, pause the video, and put that into the calculator. Okay, you should have gotten $1,435.63. So over the course of 5 years, if we calculate our interest once a year, Nick would have made $1,435 at the end of 5 years. Now I'd like to show you how to use this formula for semi-annual. So A, we want to find out. P is what we are starting with. So Nick is starting with the $1,000. 1 plus my rate divided by my number of compounds. So my rate is 0.075. My number of compounds is N, and in this case it's semi-annual, so it's 2. And up here is to the NT power. So the N is 2, and the number of years, T, is 5. So 2 times 5. Now we want to be very careful about how we put this into the calculator. You have to simplify this first before you can do anything. So we're going to write A equals 1,000, 1 plus 0.075 divided by 2 to the 10th power. Now you can go ahead and type this into the calculator just the way you see it, and don't forget to put an extra set of parentheses around that piece in there. Alright, hit resume when you're ready. Okay, you should have gotten A is equal to $1,445.04. So adding one more time that we calculate interest, right? If I went from once a year to twice a year, you made just a little bit more money than you did if it was annual. So do you think you'll make more money or less money for quarterly? And the answer is more. You should definitely make more. So what I'd like you to do is use this formula for quarterly, monthly, and daily, and figure out how much money you should make. And this will be your homework, okay? So in order to get credit for this homework assignment, you're going to have to do these 3 problems. So I want you to plug in and see what you get. and leave the rest of this packet blank because we're going to go over it in class tomorrow. All right, have a good night.